Hello, everyone. Welcome to my talk regarding Kerberos authentication updates in Samba 4.16. My name is Stefan Metzmacher. I'm a member of the Samba team and working for SerNet, where I typically develop Samba extensions on behalf of our customers. So the agenda for today, first, a few references to other presentations I gave and Andrew Bartlett gave during Samba XPs. Then we will talk about testing improvements in the MIT Kerberos KDC, our updated Heimdal snapshot we have in Samba 4.16, pending Heimdal fixes, future updates, and how you can reliably change a machine password, which is a critical aspect of all domain join aspects. So as a start, I gave a talk about Kerberos and explained the details of the protocol and extensions in my Samba XP talk in 2020. So if you are interested in low-level Kerberos details, please have a look at that one. Then regarding security updates, in November 2021, we fixed a lot of security problems related to Kerberos, mostly related to name-based races. Let's see Andrew's Samba XP talk from 2022. It was just 1 or 2 weeks ago. So maybe you need to wait until they are published on the Samba XP website or on the related YouTube channel, but you will find it there sometime in future. So regarding testing improvements, in 2020, we introduced Python-based protocol tests, which are able to generate any possible request PDU, verify all PDU fields in the responses. And this is really important in order to torture and verify the behavior of a KDC, which we have to ship as Samba Active Directory domain controller. So this was a critical step forward. We have similar tests for other protocols, RPC, SMB, and so on, but we always lacked protocol tests for Kerberos, which were able to do similar things. The core infrastructure consists of 3,500 lines of code, including the auto-generated ASN1 code. So this was more an example how to do this, and just with a very simple test to demonstrate it. Now in 2022, these tests have expanded a lot. We are now at about 21,000 lines of code. And these tests helped a lot in exploring and fixing security problems. And also they are used as regression tests when we change the KDC code and improve things there. But still, there's a lot of things to test. A lot of details are missing. So in future, we will add even more tests there. Regarding the MIT KDC improvements, so we have that. It's experimental at this point, but in the recent past, we added Pknit Support, which is certificate smart card-based authentication, SVU to self. This is used for applications which use name-based authentication with clear text passwords. For example, they can ask for a Kerberos ticket that looks like a Kerberos ticket it would get from the client, but this is requested on behalf of the user against itself in order to find out the authorization data for the user, so the group memberships and similar things. SVU to proxy is very similar, but it's more like a proxy-based protocol where the proxy can impersonate a user based on a real ticket or an SVU to self ticket, and ask for a ticket in order to connect to a third service in the backend. There's also a few variants of that, and the resource-based constraint delegation is one of them, and that support was added recently for our MIT-based KDC code. And we also added some asserted identity sets in the pack in order to distinguish between normal authentication and SVU to self authentication. So the S1.18.1 SID is normal authentication, and S1.18.2 indicates that SVU to self was used. And maybe administrators want to have echoes based on that in order to prevent SVU to self access to resources. So, as I mentioned, this is still experimental and hidden behind with experimental MIT ADDC configure option. And Heimdal-based KDC is still the preferred choice. And the new features above require MIT 120, which just got released 2 or 3 weeks ago on May 26th. In 2022. But the good thing is that the Python tests give us an overview what is still missing, and that is getting less and less. So regarding the updated Heimdal snapshot, so for Samba 4.15, we basically had the same Heimdal snapshot as we had with Samba 4.0. So we did the last import from upstream in 2011 and only fixed important bugs in our copy of the tree. With Samba 4.16, we imported a fresh Heimdal import. That means we rebased our few custom patches, and we still have some of them, but they're rebased on the upstream master branch. And we try to create upstream pull requests for every new custom patch we add, and try to get it upstream there first, but sometimes it takes a while, so we have no choice and need to keep the custom patch in our tree. The new Heimdal internal APIs are much more flexible. They make it much more easier to hook our ADDC KDC logic into the core code, and hopefully with that we require less custom changes for future features we will add there. So the most important update, or the most important feature we got with the update, is the Kerberos fast support. This is some kind of armoring of Kerberos requests, so they are tunneled inside Kerberos encrypted packets. So it means that when you have a machine password from a computer account, for example, that has a strong password, it will do Kerberos authentication first, and then password authentication with maybe weaker passwords from users are encrypted inside the tunnel of the strong password on the machine account, and that avoids offline attacks with snooped Kerberos request. So for now, we don't support the compound identity feature, which is also available with fast in Windows. That means that the resulting pack, the authorization data, also contains information about the machine account, the device the users logged into. But we don't support that yet, but the new infrastructure in Heimdal would allow that. So as a client, fast is used in Heimdal and MIT by default if possible, but it means it's not used for authentication ticket requests, which would be the most important thing because of the weak password problem. So the pre-authentication is not protected by default because there's no machine account by default. So applications have to do that manually and don't get it for free. But for service ticket requests, it's used by default. And there's some downgrade detection between the KDC and the client in order to safely use it without downgrades. Windows clients don't use fast by default. They require at least the Windows 2012 DC, and also explicit GPU settings are also required in order to let Windows clients use fast. And one problem is that we announce ourselves only as Windows 2008 or 2 DC. So there's more work required in order to have Windows clients using fast in a Samba domain. Because we guess, or we fear that announcing ourselves as a higher level may have undesired side effects. So there's a bit research needed, but in future we will also support it for Windows clients. But the good thing is that the infrastructure is now there, and it's just a matter of implementing it in Samba. So some pending Heimdal-based fixes or updates I have in the queue. One thing is regarding previous passwords not being used when changing or when authenticating a user. So when a user's logged into more than one computer and maybe maps a network drive using Kerberos, typically the client-side application, the Windows client, or maybe also a Linux client or so, will cache the password in clear text in order to re-get a fresh Kerberos ticket if re-authentication is needed, for example, for an SMB session. And when that happens and the user changes the password in between, it means that the cached password may re-trigger re-authentications with the old password, and that results in the account being logged out quite soon, typically after 5 attempts or so. And with NTLM, we have that already fixed. So we look up the password in the previous passwords in the history. And if it's there, we don't update the bad password count. And with the bug 14054 and the related merge request 664, I have patches to fix this also for the Kerberos case. There are some changes also needed for upstream Heimdal, and there's also merge request for that. And hopefully with Samba 4.17, we will get that fixed. there are important fixes regarding SVU to proxy support for Windows consumers, because they use the encrypted authorization data field in the Kerberos requests, and in combination with SVU to proxy, we end up using the wrong decryption key and fail the request, therefore. And bug 13131 has patches to fix that. And there's a second problem where we don't use the correct auth time for the resulting pack. So with SVU to proxy, you typically get 2 tickets, one for the service and one for the to be impersonated user. And we need to get the auth time from the service ticket for the service, and the rest of the details from the user ticket. And this is tracked under bug 13137, and both problems are with their fixes in merge request 2458. So the next important thing is there's a PA supported E-types field in the responses from the KDC, and they are used to announce encryption types which are available for the specified account. And there are some differences between what we do and what Windows is doing. And for example, with an account having only RC4 HMAC MD5 keys, but if that has still support for the newer AES-based encryption types, then we won't support the new AES types. But with the problem fixed with bug 13135 and merge request 2459, we have fixes for that and now behave like a Windows server, where the result is that we have a ticket encrypted with the ARC4 HMAC MD5 key, but the session key inside is based on AES. So for the future, as mentioned before, the compound identity support and also claim support is not there yet, but the new Heimdal KDC APIs will make it much easier to add that, to analyze the data we get from the client, and also insert new fields into the pack buffers. And the other important thing is that we can change WinBind to actually use armoring for the Kerb5 authentication request used by PAM WinBind, and that will then prevent the plain pre-auth packets with the weak passwords on the wire. So in order to show that it's really important to behave very, very similar to Windows Server, I am taking the example of changing a machine password and how that went wrong in the past in Samba, and what we tried to fix it, and finally, or hopefully finally, manage to behave in a way that is very robust and protected against failures. So in general, passwords on Windows are based on UTF-16 up to 255 characters, and that's converted to UTF-8 in order to calculate Kerberos keys, AES keys mostly, and it's the UTF-16 is a raw input for the MD4 algorithm, which is unsalted to generate the NT hash, which is also used for the ARC for HMAC MD5 Kerberos keys, but also for NTLM authentication. And machine password should be as strong as possible in order to protect NTLM pass-through authentication and also the Kerberos fast tunnel. So what we did is, first we tried completely random passwords having a length being random 2 between 128 and 255 characters. Each character was be able to be a random 32-bit code point, and that's resulted in our bug 12262. And the problem there was that after the machine password was changed, Kerberos was no longer working. And after a lot of debugging, I found out that it partly depended on the Unix charset being used. And there was also a problem with the logic in Heimdal and MIT libraries in order to convert UTF-16 to UTF-8. And these didn't support the 30-bit code points with UTF-16 compound characters. So, because of that, we limited the characters to be just 16-bit code points and make sure that they are really valid code points before we use them. So we added conversations from UTF-16 to UTF-8 and back to UTF-16 again in order to make sure that the conversions are compatible in both directions. And for the example with a Unix charset not being UTF-8, we added a fallback to random ASCII characters if the conversation fails to be unique in both directions. So with that all fixed, we still hit a problem. So years ago, we had a report where password change caused problems because after we changed the password on the server, we were failing to store the password in the local database once Samba running in a CTDB cluster. And the result was that the cluster was no longer joined to the domain because the domain controllers had the new password, but we wasn't be able to store that. So with that, we changed the strategy and stored the password first locally and then changed it remotely. But so the assumption was that when we were able to talk to the DC a millisecond ago, we didn't expect problems to happen during the remote change. But it turns out that's quite easily not the case, because there's a feature refuse password change. And if a DC sets that it will always report wrong password and don't change it. So we were still kicked out of the domain because we changed the new password locally, but were not able to change it on the server. We still stored the previous password, but we didn't have logic to recover that. And also for Kerberos authentication, we don't have any fallback to the old password. So what we do now is we store 3 or 4 generations of passwords, older, old and current, and optionally also the next password. So before we try a remote change, we first store the next password change. So we pick a new random password, store that, and if there is already a stored one, we will reuse that. So this is important to do. And before we do the remote change, we first check which of our 4 passwords the new DC already knows about. So we try authentications with all of them, or we start with the current, I guess, and then the next, if it's there, and then old and older. And then we find out which ones the server knows about. If it already knows about the next change, we can just finish the change locally and store it as current password. And this is to recover the case where we stored the new password change. But when we did the remote change, we don't know if the problem was on the way to the domain controller, on the way back, or when we stored the final password change in our database. In order to recover that, we have the logic to check for the next change. If it turns out that the server only knows about our old or older password, then we just stop and retry later with some randomized latency and wait for replication latency to recover. So the case is most likely that we change the password against a different domain controller, and the one we're talking against now doesn't have the password yet. So in order to prevent further problems, we just stop at that point. And if everything goes wrong, an administrator needs to fix things up later, but that is typically not the case, because we will still work with the older passwords. So if all the checks went through and we know the server has our current password, we do the remote change and then store the result of it, either success, or we store that the password change failed remotely, and then we also store the server name and the error code in order to have administrators to look at it. But it still means we are in the domain and can work against domain controllers. So even with that fixed, we were still not safe with our password change journey, because of a problem we hit when we changed the password against the read-only DC. And the problem is that a read-only DC just forwards the password update to a read-write DC. This is handled via the log on send to some request. But the problem is that the read-only DC seems to truncate the password on 256 bytes, which means we get just 127 or 28 characters, and the read-write server, would then fail the request with invalid parameter, and the read-only DC still supports success to us, which means we finalize our password change. And might still be out of the domain because the password change is only stored in our database, but never reached up at a read-write DC. So we're finally back to what Windows was using, just the fixed length of 120 characters. And with that, we can now reliably change the password against the read-only DC. And hopefully, this is the end of the password change problems. So the important thing here to keep in mind is that this is just an example, and we had a lot of similar cases in the last 20 years. It most likely always turned out that it's a good thing to behave like Windows bit by bit, in most cases, because otherwise we just hit untested code in Windows itself or in third-party vendor code, which is only tested against the Windows server. With that, I'm finished with my talk. Feel free to send me questions or feedback on my email address. Thank you very much for your attention. Goodbye.